I want to talk about groundwater. Now, groundwater has more than 100 times the amount of fresh water than in streams and lakes combined, and we are hugely dependent upon it for our agriculture. However, groundwater is an incredibly delicate resource. It's hard to get out of the ground, it's slow to recharge, to refill, and it's easily contaminated. Now, despite misconceptions, groundwater does not exist as huge, large underground rivers or lakes. It's water that exists in tiny pore spaces that are actually within rocks and soil. Now, I've already shown you that solid rock isn't immovable, that it still flows. That was the whole foundation for mantle convection. Well, it turns out that solid rock isn't even solid. Even igneous rock contains small amounts of water within it. The water exists actually within the rock, within small pore spaces or along the boundaries between mineral grains. And that water can flow through the rock, even rock that we think to be or would view as being entirely solid. Now, more water exists in rocks that have a high porosity. And porosity is a measure of how much of that rock is actually empty space. Rocks like sandstone and shale or eroded limestone, primarily sedimentary rocks, tend to have very high porosities. They hold a lot of water within them. Why? They form often from clasts, from particles, from bits of sediment from previous rocks. And when those clasts got stuck together, there are often spaces in between them. Often those spaces get filled with cement, but often they remain as empty space. Good places to store water. Igneous and metamorphic rocks, which often form directly out of a magma, crystallized from a magma, or in the case of metamorphic rocks, are squeezed and compressed so the pore spaces are removed. These rocks often have very low porosities. But even they can have non-zero porosities, especially when they're fractured, because the cracks that can develop in a rock can provide avenues for water to travel through. Now, the water flows through rocks more easily if they have a high permeability. And the permeability is the measure of how easy it is for water to move through that rock. High permeability occurs when the pores within a rock are well connected and they develop channels for that water to flow. Sandstone and limestone tend to have high permeabilities as well. The water can flow through them easily. And again, the igneous and metamorphic rocks usually have quite low permeabilities. However, there's a little bit of a surprise here because the rock shale, which often is hugely porous, in other words, as much as 30% of a shale may actually be empty space, it has a very low permeability. Why is this? Because the pores are so small that they don't make it easy at all for the water to flow through. I can demonstrate that with two different types of sand. Now, interestingly, we discovered this here in the lecture hall when we were trying to do the demonstration on making sandcastles, and we used this sand here, which is very fine, and it just didn't work because the water didn't sink down into it. Let me demonstrate. Here's sand that's fairly coarse, and if I pour water into it, you can see the water just soaks right into it very quickly. However, if I take the sand next to it and pour water into it, that water sits on top of the sand. Why is that happening? Well, it turns out that the porosity of both of these sands is about the same. There are lots of little sand grains attached together, and the absolute size of them doesn't matter. But in this sand, the sand is so fine that there aren't good channels. It takes a long time for that water to sink in. Now, if I were to let this sit here overnight, the water will eventually percolate down through it. But it has a very low permeability, so it's going to take a long time. Well, for human use, we want rocks with both a high porosity and a high permeability. And we have a special name for those rocks. We call them aquifers. They are good for human use because a lot of water can reside within them and it can move through them quickly. So if we pull that water out, more water is going to flow in to take its place. And sandstone, made from compacted sand, is often the best aquifer, preferred if you're drilling a well and you want to pull water up from underground. Now, there are also layers of rock that prevent the flow of water, and those are called aquitards. Here it would be a rock, often a shale, where water is just not able to cross it very easily. Again, over geologic time, the water will still flow through it, but over the scale of human usage, it just doesn't allow the water to flow through efficiently enough to allow it to be used as an aquifer. Now, an important thing to remember with groundwater is that the source of all the water is from above. It's rainwater that seeps into the ground and percolates downward from the force of gravity. So the aquifers get their water initially from above, and the rainwater that goes into it can take either a short amount of time or enormously long periods of time. Now,